Okay, so what level of confidence do you have in working on these two
I got the
problems?
first step.
No.
The first one?
Actually,
The first step on the first one?
I have almost the first one done.
Yeah.
I have a good 90% confidence, but that 10% is really kind
If
of
I
like
keep trying, I can get it.
Okay, good. What, Carson, what
Do I
about
have
you?
to solve for the cube root of 4/3? Negative 4/3?
Yeah.
Okay.
On number 2. Or am I just...
So what we do is horizontal tangents are where the derivative is equal to 0, right?
I was gone for way too long.
So we say g prime of x is equal to 6x minus 7, right?
Yeah.
80.
Okay, that's right.
So if we say 0 equals 6x minus 7, we solve for x,
It's 7/6, right?
x is equal to 7/6. So that's going to be where, so that's the
That's
answer. Now, we could actually find also what that equation is, can't we?
That's the answer?
Yeah, huh?
Not the
Oh.
answer.
And we can find the equation by putting in, I guess we could plug in, right, to this one here.
Are we not supposed to
Find out.
plug it in?
No, you're not. You don't need to.
Oh my god.
Did you?
Yeah.
Did you do more work than this?
I did way more work than I needed.
I got the answer.
I found the point of where it...
We found the point. What was the point you got, Aaron? Thinking.
7/6 and then negative 37/12.
Okay, 7/6 and then negative 37/12.
Yeah.
Yeah, so that was a really tedious fraction workout, wasn't it?
Yeah.
So then the equation is going to be y equals negative 37/12, right? That'll be our tangent line, okay? So I'm glad you did that, Aaron.
I didn't know.
Even though you
That's what I
did.
was doing. I was in the process of plugging it in.
Were you? Yeah.
Yeah, because I got the 7/6.
Yeah, so this is just asking for where, which is limited to find the 7/6.
That's another way of saying like the x value.
So anyway,
Wow.
for this second one here, I'm going to have 2/3 x to the negative 2 power is what that is going to be. So y prime is going to be like negative 4/3 x to the negative 3 power. So that's going to be negative 4 over 3x to the 3rd power. And if we set this equal to 0, we say 0 equals negative 4 over 3x to the 3rd power. And we solve for x. What is x?
The cube root of negative 4/3.
Oh. Okay.
Anybody see something here? I want a light to go on here.
A light, huh?
There should be a light that illuminates. Is this a possibility?
No.
This is not a possibility, okay, because there's no value of x that's going to make this a true equation. So there are no horizontal tangent lines. So x cannot be solved for, or there's no solution. So no solution. Therefore, no horizontal tangent line.
See, if we would have done this before we went on break, I probably would have got it better. But
Well, I want to show you something.
my brain is lost.
I want to show you something. This is actually, we did actually go over this before we left. That's how long ago this was. This one right here, this problem 2, we did this before we left. So you actually saw a version of that before we left. That's how long ago it was. So anyway.
Aaron, you good?
I'm just pinching it.
Let's go on to number, yeah, so there it is. So go ahead and do number 3. I think number 3 takes us into linear approximation. take attendance for you guys.
Oh,
Gavin,
Is there?
how long are you coming along on this one?
Not very.
I'm kind of lost.
Yeah.
I'm big lost.
Okay, when you take, what's the strategy?
Do we have, like,
Find the derivative of the function and set that derivative equal to
0.
I know
0.
how to do it, I just
Solve for x.
finding the derivative of this
Okay,
for like no reason is making my brain explode. Because I think I know what to do, but then whenever I write it down, it doesn't make any sense to me.
what I would do on this one is simplify it.
I think you did it wrong.
Simplification.
I feel like I'm making it look way more complicated than it should be.
So we know the function is not defined at x equals 0, but after that simplification, we're going to get, we get 5x squared
Okay, yeah.
minus 8x plus 10. And then I'd work from here. And then if we work from here, we get 10x minus 8. So if we set this equal to 0, we have 8 equals 10x. So x is going to equal 8 divided by 10, or 4/5. And then we look and we see, does that conflict at all with the function not being defined at x equals 0? No. And so this is going to be, that's going to be good, okay?
It was just simplifying it that I like forgot to do.
I mean, this first simplification here?
Yeah,
Yeah.
that's the step I was like,
Yeah, we did this. I remember we actually did this in,
After we get through this, maybe start streaming, like after everything's.
Okay. And what happened here is that
Oh my god.
we actually did a problem like this
I'm an
in
idiot.
pre-calculus,
No.
section 2.4. And how do
Oh,
I
no,
know
no,
that?
no,
Because
no.
that's what we recently worked on.
it's like, in my head, that's what I was like supposed to do. I just couldn't like write it down the right way. I don't know, dude. It was a lot.
Yeah.
I haven't been here in a while. My brain is recuperating.
Now we're going to finish up this part of the packet, which is number 20, which is called linear approximation. And linear approximation is, it's making use of the reality that you can estimate that if you look, for instance, at this curve drawn, as you can see that it's really not too far off over this kind of domain. You see that? Not too far off. And so you can actually use a line to estimate a point on the curve if you know what that is. It says if you have a concave up function. Have we talked about concavity yet? We haven't, have we? If a function is concave down, in this instance, a concave down is like this one here, where the curve is down like this. A concave up is going to look like this. And this one here, the actual function is concave down. So if we have concave down, as in this sketch here, the approximation would be an overestimate. So if we tried to approximate using this tangent line a value on the curve, that value that we calculate is going to be an overestimate because the tangent line lies above the curve. And if we had a concave down situation like I drew up above here, the curve, the line that touches that, that's going to represent an underestimate. See, because the tangent line lies below the curve. So you have to look at that. So basically, you're extrapolating values depending on where that is.
Extrapolating, that's a fun word.
Yeah, it is a fun word, and so it's a good word. It's something that that you can impress a lot of people with that.
I like that.
Also, interpolate and extrapolate. Interpolating, do you know what interpolating is?
I don't.
I've been talking about that. Now, interpolating means, extrapolating means going outside the known data set. So by that definition, predictions of the future are always going to be extrapolations, right? But interpolation means within a data set. So if you have a known data set, it's probably more dependable. Interpolations are usually more dependable than extrapolations. So that's something that I started talking about with the Algebra 2 students, you guys. So that's an impressive sounding word you can use. We're going to extrapolate. It's a fancy way to say predict in the future. So, and then we have this one here. Yeah, let me see. I want to do this one. Let me just show you here because I worked it out. Okay, what happens on this one here, given the function fx equals x to the fourth power minus 3x squared, write an equation line tangent to f at x equals -2. And the same thing we've done here with point and slope. You see that? I don't know if it says what the slope is. Yeah, f prime of -2. So this right here. So this is our slope. And here's our equation of the line, and then we can use this equation to estimate what f of -2.1 is by just plugging into this determined tangent line equation the value of -2.1. So this provides an estimate for us. And I don't know, I'm trying to see if I can call from this if this is concave up or concave down. I know it's going to be, the function's going to be overall concave up since this thing starts high and ends high. That'd be my guess. That's probably going to be an underestimate. I'm not exactly sure what it's going to be. Let's see. In fact, I want to put this in the calculator. -20x minus 36. Yeah, let's do that.
Mr. G.
Yes.
How are you, sir?
-20x minus 36. Then the other equation was x to the fourth minus 3x squared. So we graph both of these. And really this is the tangent line right here. And we could see the intersection point, second, trace 5, enter. Yeah, so this is going to be our intersection point right here. And then we said if we put in negative 2.1, so y equals negative 2.1. Let's do it this way. Negative 2, we'll go by 0.1. We go to table view. We should be able to see it. And so here we have, this is the actual curve here, and this is the estimate. Okay, you can see that within that narrow confine, that thing is pretty quick. And also, remember I told you I thought it would be an underestimate. Well, the reason I thought it was an underestimate is I knew that this function is going to be concave up, and because that's concave up, the answer is going to have to lie below the curve. Now I wasn't 100% sure because it could have been concave down in this interval right here. But anyway, so that's that one. What I want to do is this. Yeah, go ahead and do problem number 2. Work that, it gives you enough information to solve that one.
I'm waiting for them.
I didn't know. I heard the clip and she was out. I heard the camera.
Okay.
I'm gonna be honest, Mr. G. I don't know what to do with this graph or this table.
Okay. If you look at the note card thing there. I will show you here. Okay, what you do is you say, okay, use the approximation of f at x equals 1, so to approximate the value of f of 1.2. So you look for,
Oh, wait, okay.
you look for the equation of the tangent line first.
Yeah, okay.
And what do you need for a tangent line?
Slope and a point.
Slope and a point.
I got it now.
So we're going to use this one right here. So our point is going to be 1, 10, right? And then slope is going to be f prime of 1 is 5. So we're going to have y minus 10 equals 5, x minus 1. And one thing I do recommend doing on these is actually solving for y, because it makes your job easier when you consider that. So we're going to have y minus 10 equals 5x minus 5 and add 10, we're gonna get y equals 5x plus 5, is that right?
Yeah.
5x plus 5. And now we can plug in 1.2, so y of 1.2 is going to be 5 times 1.2 plus 5, so that's going to be, I think, 6 plus 5, so that's going to be 11. So that's going to be your approximate. And we're told that we're concave up, so is this going to be an overestimate or underestimate?
Underestimate.
Yeah, underestimate. Under because concave up. And we haven't talked about concavity yet. That's coming shortly to us. And visually what that looks like is like what that last one looked like. Okay. Okay, now we're getting into our next note card, our next packet, which is normal lines. And normal line to a curve at a point is a line perpendicular to the tangent line at that point. And so we're looking for a slope that's the opposite reciprocal slope. So the basic thing is, if we have a line, for instance, and that line and the slope of this one here is going to be 1/2. If we have a tangent line, I mean a normal line here, m sub n is going to be -2. So it's the negative reciprocal. These are negative reciprocals of each other. All right, so, but otherwise it's very much the same as when we worked on tangent lines. So what I want you to do for number 1 is find an equation of a tangent line and a normal line for this one right here. So what I'm getting for here is this, for a tangent line slope and for a normal line slope. And so what you're going to have is, for your tangent line, you're going to have y minus 3/16 is equal to 332 over 32x plus 4. So this will be your tangent line. And your normal line is going to be the same thing except what? How is this going to be different, our normal line?
It'd be negative 32 thirds.
Negative 32 thirds. And x plus 4. So this is, so that's what it is. So you have tangent line. And normal line. And that's really all there is to it. So it's not, I don't think this is this hard. If you have the tangent line figured out really well, this is just a very minor extension of that. Okay? All right, let's get to next one. Yeah. Okay, so here's another one, number 2. Find the slope of the line normal to this graph here at 9, comma negative 6. When you do these types of problems, one thing that always causes the alarms come off a little bit. You say, well, I wonder how complicated is that number going to be? Well, you have a square root of 9 in the answer someplace, and so that's you're gonna have an actual rational number.
Oh, that's not boring. No wonder.
So I'm getting negative 7/3 for that. And so if,
Isn't it minus 2?
should be minus 2, yeah. So that's going to be
Negative
5/3.
4/3, I thought.
4/3, yeah. That'll be 5, that'll be 6/3. Yeah, so it'll be negative 4/3. Yeah, I miswrote that there. Thank you for catching that.
That's a sticker.
Yeah, yeah. So MT equals negative 4/3. What is M sub n going to be? 3/4. So we're gonna get y plus 6 equals 3/4 by x minus 9. So that's gonna be our tangent line. I mean, our normal line, okay? So really, that's all there is to it. So that shouldn't be a whole lot to that. And let's see what else we have here. Yeah. And it says find the slope of the normal line. So obviously 3/4 was really our answer, and this is our extra work here that did. Okay, and let's see, this one, number 3, we're going to be talking about our breakpoint tomorrow on that. So I think we'll come back to this tomorrow. And